What if the reality you perceive is solely shaped by your observation? Does the simple act of observing influence the state of existence? In an expedition into the very core of reality, let's explore how observation might be the architect of the world we dwell in. Picture a realm where reality isn't as rigid as you imagine, but instead it waltzes to the beats of perception. Such a notion might echo the plot of a sci-fi story, yet it is a genuine inquiry that has been the crux of philosophical and scientific arguments for ages. The crux of reality. Is it objective or subjective? Is it autonomous from our perception, or is it engineered by our consciousness? How does quantum mechanics relate to this? Enter the quantum measurement problem, a paradox that sits at the heart of quantum physics. This is a domain where particles aren't merely in one position or another, but in all positions simultaneously. They reside in a superposition of states, a medley of potentialities until they are observed or measured. Ponder over a flipping coin. While it's airborne, it is both heads and tails concurrently. The moment it settles, the moment we observe it, it plunges into a single, precise state, either heads or tails. Particles in the quantum world have a similar pattern. They exist in myriad states concurrently, but when we opt to measure them, they suddenly pick one particular state. It feels as though observation coerces them into making a decision. This paves the way for a proposition. Is consciousness a key player in sculpting reality? Alternatively, does an objective reality exist, unaffected by our perception? This query puts our comprehension of the cosmos and our place in it to the test. Hence, the mere act of observation could potentially be molding the reality we live in. So, what is this quantum measurement problem we talk about? Let's break it down. The quantum measurement problem is one of the most intriguing puzzles in quantum mechanics. It's the question of how or why the act of measurement or observation can fundamentally change the state of a quantum system. Now let's make this a bit more tangible with an example you might have heard of: Schrodinger's cat. In this thought experiment, a cat is in a box with a device that has a 50% chance of killing the cat. According to quantum mechanics, until we open the box to check, the cat is in a superposition of states. It's both alive and dead at the same time. But here's the twist. As soon as we open the box to observe, the cat is either definitely alive or definitely dead. But why? This is the crux of the quantum measurement problem. The act of observing or measuring somehow collapses the superposition into one of the possible definite states. But how does this happen? Why does our act of observation determine the cat's fate? And what does observation even mean in this context? Is it the human eye that causes the collapse? Or is it the light particles bouncing off the cat? Or perhaps the air particles in the box? Quantum mechanics, as it currently stands, doesn't provide a clear answer. The quantum measurement problem highlights the strangeness of the quantum world, a world where things can be in multiple places at once, particles can be entangled over vast distances, and the mere act of observation can determine reality. It's a problem that shakes our understanding of the universe and our place within it. That's the quantum measurement problem in a nutshell. The act of measuring or observing decides the state of the system. Now, where does our consciousness come into play in this quantum world? The concept of consciousness in quantum mechanics is a topic that has sparked a myriad of discussions and theories. Some of these theories propose that our conscious minds play a vital role in the quantum measurement problem. To put it simply, they suggest that our consciousness might be the reason why quantum possibilities collapse into definite realities. One of the most debated theories is the von Neumann-Wigner interpretation. Named after the brilliant minds of John von Neumann and Eugene Wigner, it suggests that the consciousness of an observer is key to the collapse of the quantum wave function. In other words, when we observe or measure a quantum system, our conscious minds are what coax it out of a state of multiple possibilities and into a single, definite reality. But how could this be possible? How could our minds have such power over the physical world? The answer lies in the peculiar nature of quantum mechanics itself. Because quantum systems exist in a state of superposition, where they can be in multiple states at once, it's our observation that forces them into choosing one state. This brings us to the idea of consciousness causes collapse. It's the notion that the act of conscious observation is what triggers the collapse of the quantum wave function. It's not just the act of measurement, but the involvement of a conscious observer that brings a quantum system from a state of maybe this, maybe that, to a state of definitely this. However, it's important to note that this interpretation is not universally accepted. Many physicists argue that consciousness has nothing to do with the quantum world, and that other factors are responsible for the collapse of the wave function. So it's possible that our consciousness is not just a passive observer, but an active player in shaping reality. But this leads us to another question: is there an objective reality independent of our perception? In the realm of quantum mechanics, the concept of objective reality is a hotly debated topic. Objective reality, as we understand it, signifies a world out there that exists regardless of our observation or perception. It's a world that is concrete and absolute, unchanging in the face of our individual interpretations. However, quantum mechanics throws a wrench into this idea. It suggests that the act of observing or measuring can potentially change the state of a quantum system. This is a stark deviation from our traditional understanding of the universe, where things exist in a definite state whether we are looking at them or not. Consider the famous double-slit experiment. When not observed, a single particle appears to pass through both slits at once, creating an interference pattern as if it were a wave. However, when observed, the particle behaves differently, passing through one slit as if it were a particle. This experiment indicates that the act of observation influences the outcome, challenging the notion of an objective reality. Some argue that this doesn't negate objective reality but rather shows our understanding of it is incomplete. They suggest we need a deeper, more nuanced understanding of reality that incorporates these quantum quirks. On the other hand, others argue that this experiment, along with others, suggests that consciousness plays a role in creating reality. They propose that reality is a construct of our collective perceptions, a mental model shaped by our interactions with the world. As we delve deeper into the quantum world, these questions become ever more complex, challenging our understanding of reality and our place within it. As you can see, the existence of an objective reality is not as straightforward as we might think. So we've journeyed through some profound concepts today, haven't we? It's been a fascinating exploration, and we've touched on some of the deepest questions about the nature of our universe. We started by delving into the nature of reality itself. This isn't just a philosophical question. It has real implications in the world of quantum mechanics. Reality as we perceive it is fundamentally different at the quantum level. Particles exist in multiple states at once, only settling into a definite state when measured. This is what's known as the quantum measurement problem. This leads us to the next big question we tackled. What constitutes an observer? How does the simple act of observation collapse a quantum system into a definite state? It's a puzzle that has been the subject of much debate and controversy in the scientific community. Some believe that it's the interaction with the measuring device that causes the collapse. Others propose that consciousness itself plays a role. This brings us to the role of consciousness. Could our minds, our conscious awareness, be affecting the very fabric of reality? It's a tantalizing idea, one that blurs the line between science and philosophy. While the jury is still out on this, it's a question that continues to inspire and provoke thought. Lastly, we asked, is there an objective reality? Is there a world out there that exists independent of our perception? Or is the universe in some sense a construct of our minds? Again, there's no definitive answer to this yet, but it's a question that challenges our deepest assumptions about the world and our place in it. While we may not have all the answers yet, it's clear that our understanding of reality is deeply intertwined with the mysteries of the quantum world. As we continue to explore these questions, one thing is certain: the universe is far more fascinating and complex than we could ever have imagined. We've embarked on a remarkable journey today, delving into the mind-bending world of quantum mechanics. We've explored the enigma of reality, the puzzling quantum measurement problem, the intriguing role of consciousness, and the philosophical question of an objective reality. But what does all this mean? What are the implications of these groundbreaking concepts? Firstly, these ideas challenge our fundamental understanding of the universe. They push us to question the very fabric of reality and our role within it. The quantum world is not just a realm of tiny particles, but a landscape of endless possibilities and paradoxes. Secondly, these concepts open up a new realm of scientific exploration. They provide a framework for understanding the universe at its most fundamental level. They might even hold the key to unifying the disparate realms of quantum mechanics and general relativity, the holy grail of modern physics. Thirdly, they remind us of the power and mystery of consciousness. If consciousness plays a role in shaping reality, as some theories suggest, then the mind is not just a passive observer, but an active participant in the unfolding of the universe. But perhaps the most profound implication is the humbling reminder of how much we still don't know. The mysteries of the quantum realm are a testament to the complexity and wonder of the universe. They remind us that we are part of a grand cosmic narrative filled with mystery, beauty, and infinite possibilities. As we wrap up our journey today, we're left with more questions than answers, and that's the beauty of it. In the words of physicist Richard Feynman, I think it's much more interesting to live not knowing than to have answers which might be wrong. So as we delve deeper into the quantum world, let's embrace the unknown, the mysterious and the awe-inspiring, because in the end, the universe isn't just something we study, it's something we're a part of. And that, in itself, is a quantum conundrum worth pondering.